Hey everyone, in today's video we're going to be talking about special angle triangles. So these are a couple of different triangles with specific side lengths that you'll need to know for a lot of future math concepts. And a lot of your future problems will involve ratios, including the side lengths of these triangles. So let's get started. On the very left hand side over here we have a triangle, and it's called the 30, 60, 90 triangle. Why? Because we have one angle that's 30 degrees, one that's 60, and one that's 90. So the most important thing to take note of in these special angle triangles is the side length. So if you look at the side that's adjacent to the 30 degrees, so this one over here, it has a side length of square root of 3. The side opposite to the 30 degrees, so this one over here, has a side length of 1, and the hypotenuse has a side length of 2. That's all you really need to know from the 30, 60, 90 triangle, and you'll use these three values as ratios when you're solving future problems. So let's work on our next triangle. So if you look over here in the middle, I've drawn another triangle, and they both are the same thing. So this first triangle and this second one are the same exact triangle. The only difference is that I've switched around the 30 degrees and the 60 degrees. So let's take note of the side lengths. As you can see, the side length adjacent to the 60 degrees is 1. The one opposite to the 60 degrees is the square root of 3, and the hypotenuse is equal to 2, just like in the first triangle. So this is called a 60, 30, 90 triangle, and it's the same as a 30, 60, 90, except I've switched the position of the 60 and 30 degrees. So now let's look at our last triangle. It is a 45, 45, 90 degree triangle. So one angle is 45 degrees, one angle is 45 degrees, and the last one is 90 degrees. And now let's take note of the side lengths. This is very important. The side that is adjacent to the 45 degrees, so this one has a side length of 1. The side opposite to the 45 degrees also has a side length of 1, and your hypotenuse is equal to the square root of 2. So it's important to note these three various side lengths for future math, and also just to sort of find various values from these triangles. So now let's work on finding sine, cosine, and tangent of these specific triangles and their angles. Okay, so what we're going to do now is figure out the sine, cosine, and tangent values for our 30 degree triangle. So this is our first one. So if you see here on the left, we have our 30 degree triangle with a side length of root 3, 1, and 2. And over here, I've written down SOHCAHTOA on the right. If you don't know what SOHCAHTOA is, all it stands for is sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to the opposite over adjacent. If you don't understand this, make sure you go check out my other video on sine, cosine, and tangent. So what we're going to be doing now is figuring out the sine, cosine, and tangent values for the 30 degree triangle. So let's do sine of 30 degrees. Sine of 30 degrees is going to be the length of the opposite over the hypotenuse. Now if we look at our 30 degrees over here, the length of the opposite is 1, because this is the opposite side. So it's going to be 1 over, and next is the side length of the hypotenuse, and the hypotenuse is always going to be 2, so it's 1 over 2. So sine of 30 degrees is 1 over 2. Now we're going to do cosine of 30 degrees. Cosine of 30 degrees is equal to the adjacent over the hypotenuse because of our SOHCAHTOA abbreviation over here. In this case, the adjacent side to 30 degrees is the one that runs along it, so it's going to be square root of 3. So the adjacent is equal to the square root of 3 over the hypotenuse, and the hypotenuse is always going to be the same, which is 2. So cosine of 30 degrees is square root of 3 over 2. Finally, let's find tangent of 30 degrees. Tangent is going to be opposite over adjacent. The opposite side to 30 degrees is 1, because if this angle is 30 degrees, the side opposite to that, so this one over here has a side length of 1. And the adjacent one is over here, that's a side length of square root of 3. So it's going to be square root of 3 over, so it's going to be 1 over square root of 3, which simplifies to the square root of 3 over 3. So tangent 30 is equal to the square root of 3 over 3. Let's do the same thing with the 60 degree triangle. So all I've done here is just kind of flip the triangle around to have the 60 degrees sort of towards the bottom of the triangle. So let's find sine, cosine, and tangent. So sine of 60 degrees is equal to opposite over hypotenuse, as you can see in our little abbreviation thing over here. The side length of the opposite side to 60 degrees. So this is 60 degrees, this is the opposite side, and the side length is the square root of 3. So it's going to be the square root of 3 over the hypotenuse, and the hypotenuse is always going to be 2 for your 30 and 60 degree triangles. So let's do the same thing for cosine. So it's going to be cosine of 60 degrees is adjacent over hypotenuse, as you can see from over here. The adjacent of 60 degrees. So if this is the 60 degree angle, the adjacent side is the one that runs along it, and that has a side length of 1. So it's going to be 1 over the hypotenuse, which is always 2. Now let's do tangent. So tangent of 60 degrees is the opposite over adjacent. The opposite side's length is square root of 3 because it's opposite to the 60 degrees, and the adjacent side is 1. So it's going to be square root of 3 over 1, which just simplifies into square root of 3. So this is each of the individual values for sine, cosine, and tangent of 60 degrees. So let's do this again using our 45 degree triangle. So as you can see in our 45 degree triangle, we have 3 angles, 45, 45, and 90, and 3 side lengths, 1, 1, and square root of 2. So we're going to find sine of 45 degrees. Sine of 45 degrees is equal to the opposite over the hypotenuse. In this case, the side opposite to the 45 degrees is this side, which has a side length of 1. So it's going to be 1 over the hypotenuse. Hypotenuse is always going to be square root of 2 in 45 degree triangles, so it's going to be square root of 2 over 2. Now let's do cosine. Cosine of 45 degrees is equal to the adjacent over hypotenuse. Now in this case, the adjacent is also 1 because 2 sides have a side length of 1. The hypotenuse is always going to be the square root of 2, so that simplifies to square root of 2 over 2. Let's do that finally for tangent. So tangent 45 degrees is equal to opposite over adjacent. Opposite in this case, so side opposite to 45 degrees is 1. Adjacent is 1 as well, so the tangent 45 degrees is just equal to 1. So these are each of your individual values for sine, cosine, and tangent. I hope you all find this video useful, and if you have any questions, please feel free to comment down below.